Hey guys, we're going to be looking at section 4 today, which is on multiplying and dividing radicals. Today we're going to be focusing on multiplying radicals. So there's the product rule, which says that you can multiply radicands when indexes are the same. So if as long as it's a square root times a square root, or a fourth root times a fourth root, or a fifth root times a fifth root, so as long as those little numbers are the same, you just multiply what's underneath the radical. And then if you can simplify that, simplify. So the square root of 7 times the square root of 3 would be the square root of 7 times 3 is 21. Is there a perfect square that divides 21? No, so that would be as simplified as it gets. On number 2, the square root of 3 times the square root of 3. 3 times 3 is 9, so it's the square root of 9. And we all know that the square root of 9 is 3. The square root of 3 times the square root of 15. 3 times 15 is 45. Is there a perfect square that divides 45? Yes, it is 9. 9 times 5 is 45. So this simplifies to 3 square roots of 5. Number 4, we add some coefficients out front, so you're just going to multiply corresponding parts. 2 times 5 is 10. 3 times 2 is 6. Does the square root of 6 simplify? No, so that's as far as that will go. Number 5, same thing. So 2x cubed times 6x, that would be 12x to the third times x to the first. Remember, you add your exponents when multiplying, so that would be x to the fourth. When you look at that, we'll separate it into the pieces. The square root of 12, does it simplify? Yeah, it is 4 times 3. And then the square root of x to the fourth. Remember, the index divides the exponent, so how many times does 2 go into 4? Twice, with a remainder of 0. So the square root of 4 is 2. I'm going to do this part as well. That's the exponents of the x outside, so that would be 2x squared because of that 2. And then the square root of 3, remainder 0, so there's no other things in there. On number 6, looks like a lot like number 4. 9 times 8 is 72. 10 times 3 is 30. And is there a perfect square that divides 30? 5 and 6, 3 and 10. I think that's as simplified as that one gets. Okay, let's look at number 7 there. 5 times 10 is 50. 25 divides that, so that would be 25 times 2. So that's 5 square roots of 2 when simplified. Number 8, square root of 17 times the square root of 17. I don't know what 17 times 17 is, but I know that if I do the square root of 17 times the square root of 17, something times itself is just going to be 17. Much like on number 2, the square root of 3 times the square root of 3 is 3. Actually, I think 17 times, no, I don't know what it is. Number 9, multiply corresponding parts. 15 times 5 is 75. Y to the first times y to the third is y to the fourth. And then do piece by piece. 75 is 25 times 3. Y to the fourth is 2, remainder 0. So it would be 5 on the outside, y to the second on the outside, and then on the inside we'd have the 3 and the 0, but we don't need the 0 because there aren't any of them. So it looks like 5y squared times the square root of 3. Okay. Down here, we're going to just keep doing some more stuff. Looks like we've got some bigger roots. We've got just some squaring. So remember what squaring means. It means to multiply by itself. So we've got the 3 square roots of 2 times 3 square roots of 2. So we'll do piece by piece. 3 times 3 is 9. The square root of 2 times the square root of 2 is the square root of 4. What's the square root of 4? That is 2. So we really have 9 times 2. We get 18 there. Number 11. 2 square roots of 7 squared means 2 square roots of 7 times 2 square roots of 7. So 2 times 2 is 4. The square root of 7 times the square root of 7 is the square root of 49. So it's really 4 times 7. That's 28. Okay, number 12. This time we're doing cube roots. So still multiply corresponding parts. So we're going to have the cube root of what's 4 times 18. That would be 72. What perfect square, or not square, what perfect cube, divides 72? Well, 8 divides 72. It's a perfect cube. 8 times 9 is 72. What's the cube root of 8? 2. The cube root of 9, remember, does not simplify. That's not the square root of 9, it's the cube root of 9. On 13 there, 10 times 50 is, of course, 500. What perfect cube divides 500? Should be thinking 125 times 4. And the cube root of 125 is 5. So you get 5 cube roots of 4. Let's flip it over to the back, see what else we've got. Okay, looks like we've got parentheses on the back, so we're going to be just distributing like we always have. So we're going to multiply and then simplify as much as we can. So we're going to start by distributing. What's the square root of 5 times the square root of 5? That's the square root of 25. The square root of 5 times 2 is 10. Well, the square root of 25 simplifies to plain 5. Is there a perfect square that divides 10? Nope. So it just stays as 5 minus the square root of 10. On number 2, distribute. The square root of 3x times x, that would be 3x to the second. Remember, add your exponents when multiplying variables. Minus, we've got a 5 on the outside, and then 3x times 3 is 9x, okay? Now we just need to simplify the pieces. So if I break this down into the square root of 3 and the square root of x squared, clearly the square root of x squared is x. The square root of 3 would not simplify, so it goes in the back. Over here, the square root of 9 and the square root of x, if I break it down into the pieces, the square root of 9 is 3. Square root of x would not simplify. So it looks like my final answer is going to be x square roots of 3 minus 15 square roots of x. And I can't put those together any further because they are different radicals. They're not like radicals. Number 3 here, we've got 2 parentheses. So remember, we have to distribute both of them. So x times 3 is 3x. X times 2 is 2x. 2 times 3 is 6. And 2 times 2 is 4. We just have to look at each of those and do they simplify. This one, no perfect squares, no perfect squares, no perfect squares. 4 does simplify to plain 2. Everything else would be rewritten. And that's as far as it can go. These are not like radicals because 3x is different than 2x. Remember, to be a like radical, what's under the radical has to be the exact same. If you want to pause the video here and try 4, 5, and 6, you can see how you do. You can comment below and let me know how you do on 4, 5, and 6, by the way. Let's see. Square root of 3 times the square root of 3 is the square root of 9. 3 times 5 is 15. What's the square root of 9? 3. Is there a perfect square that divides 15? No. So that's as far as it will go. 3 minus the square root of 15. Number 5, 2z times z is 2z squared. This one, we'd have the 7 outside. 2z times 2 is 4z. Simplify the pieces, so we'll separate them. Square root of 2, square root of z squared. The square root of z squared is z times the square root of 2. And then here, if I separate it into the pieces 2, the square root of 4 is 2. And 7 times 2 is 14. So it looks like I have z square roots of 2 plus 14 square roots of z. Number 6, let's see how you did. The square root of x times the square root of x would be x times x is x squared. X times 2 is 2x. 7 times x is 7x. And 7 times 2 is 14. Which of those, if any, simplify? Well, x squared is a perfect square. 2 goes into 2 exactly once. The square root of x squared is x. That one would not simplify. No perfect square divides 7. No perfect square divides 14. So there's your final answer on 6. So again, let me know how you did on those. Comment below on the video. Just a couple more examples here. These ones are kind of interesting. The square root of 5 times the square root of 5 is the square root of 25. This would be a positive 7 square roots of 5. Since one's inside of the radical and one's outside of the radical, they don't combine, they just stay separate like that. Here we have minus 7 times the square root of 5 is again 7 square roots of 5. And then 7 times 7 is 49. Okay, so let's look. Square root of 25 is 5. 7 square roots of 5 minus 7 square roots of 5. Those are like radicals. If we put them together, they cancel each other out. So I have 5 minus 49. We can put those together to get negative 44 for our final answer. Number 8 here, remember what does square mean? It means to multiply by itself. So we're going to write a second set of parentheses and do the distribution. Square root of 7x times the square root of 7x is 49x squared. 7x times 2 is 2 square roots of 7x. 2 times square root of 7x is again 2 square roots of 7x. And then 2 times 2 is 4. Now we want to simplify what we can. I look in here and I see both of these are perfect squares. The square root of 49 is 7. The square root of x squared is x. I have 2 square roots of 7x plus 2 more square roots of 7x. Again, those are like radicals. 2 plus 2 is 4. Remember, the radical stays the same. You just add them. It's kind of like x plus x or anything like that. And I've got the plus 4 at the end. Does anything else combine? Doesn't look like it, so that's going to be my final answer right there. Again, if you want to pause the video and try 9 and 10, they look a lot like 7 and 8. And then once we do them, you can let me know how you did. 7 times 7 is 49. 7 times negative 4. Negative 4 square roots of 7. 4 times the square root of 7 is positive 4 square roots of 7. And 4 times negative 4 is negative 16. The square root of 49 is 7. A negative 4 square roots of 7 plus a 4 square roots of 7 are opposites. They'd cancel each other out. And then minus 16. So 7 minus 16 gives me a final answer of negative 9. On 10, you should write the second parenthesis out because that's what it means to square something, is to multiply by itself. The square root of 3x times the square root of 3x is the square root of 9x squared. The square root of 3x times negative 5 is negative 5 square roots of 3x. Negative 5 times the square root of 3x is negative 5 square roots of 3x once again. And negative 5 times negative 5 is positive 25. Okay, let's simplify. Both of these are perfect squares. The square root of 9 is 3. The square root of x squared is x. Negative 5 square roots of 3x minus 5 more square roots of 3x would be negative 10 square roots of 3x. And then plus 25 at the end. Do any of those combine any further or simplify any further? Nope. So that's going to be our final answer again. So let me know if you have any questions on this. It can be a little tedious. It can be a little tricky sometimes. So reach out if you need some help. We'll talk to you soon. Have a great day, guys. Good luck on the My Math Lab assignment.